We have it as a block of mass 5 kg is initially at rest at origin, is acted upon by a force along positive x direction represented by F is equals to 20 plus 5x Newton. Calculate the work done by the force during the displacement of the block from x equals to 0 to x equals to 4 meters. So we say that work done by the variable force is given by work done by variable force is given by F is equals to integral, okay, work done we have been calculating. So work done by variable force is given by W equals to F bar dot dx bar between the limits x initial to x final, right? As per our problem over here, our initial is 0 to final is 4, okay, it is 20 plus 5x, okay, assuming force and displacement are along the same direction, we say it is fx cos 0, f dx cos 0, okay, so it is dx over here, assuming that force and displacement are along the same direction. So it is xi, it is xf, it is f dx cos 0. Cos 0 is equals to 1. So now here, if you could consider, our work done is now equals to 20x between the limits 0 to 4 plus 5 into x square by 2, it is x square between the limits 0 to 4. So which is now equals to 20 into 4 minus 0 plus 5 by 2 into 16 minus 0. So 24 is 80 plus it is 2 ones and 2 8s. 5 8s are 40. Okay, which is now equals to 120 joules is the work done here, right? So which is matching with our third option. Hope every one of you it is clear to you, right? Moving on to our next slide. In this, you are given that a force F is acting on a particle varies with position as shown in the graph. Find the work done by the force in displacing the particle from x equals to minus a to x equals to plus a. So now here we would try to say that work done is equals to area under force and displacement graph, area under force and displacement curve, area under force and displacement curve. See now here, if you could consider, the area can be split up into two parts. This area over here, this is one area which I would be considering, and now here this is another area. So now here it is half base over here. If you are trying to consider, this part is this, the base when you are trying to consider, it is the final point over here and it is the initial point. This represents the initial point and this represents the final point in this particular region. So it is now, if you are trying to consider, final is 0, okay, final is 0 and initial is equals to minus a over here. Okay, half base into height is equals to, height when you are trying to consider, okay, it is now at minus b, time is now increasing over here, area under force and displacement. So in this, if you are now trying to consider, this would now become b over here, right? So it is now, when you are trying to consider the next one, half base into height, base over here is 2a into height over here is 2b. This 2 and 2 gets cancelled off over here. So it is minus half AB plus half, I'm sorry, not half, it is 2AB over here. It is now equals to 2 into A into B. So it is now equals to 4AB minus AB by 2, which is now equals to 3AB by 2. 3AB by 2, which is now matching with our first option, right? So now moving on to our next slide here. In this problem it is given that a force F bar equals to 2I cap plus 3J cap minus 4K cap acts on a particle which is constrained to move in XY plane along the line x equals to y. If the particle moves 5√3 meters, the work done by the force in joules is. So now here let displacement of the body be S is equals to S bar equals to xi cap plus yj cap. The magnitude S is equals to square root of x square plus y square. As per the problem, that displacement is given to be 5√2, which is now equals to square root of x square plus y square. But it is given that x is equals to y. It is given that. So 5√2 is equals to root of 2x square. That means root 2 into x is equals to 5√2. So that means your x is equals to 5, which implies that your y is also equals to 5. So now your work done would now be equals to F bar dot S bar. Your S bar is equals to 5I cap plus 5J cap, and your displacement force applied is 2I cap plus 3J cap minus 4K cap dot your displacement is 5I cap plus 5J cap. So which is now equals to 5 2s are 10, I cap dot I cap is equals to 1, and 3 5s are 15 plus 0 J cap. So that is not possible here. Okay, so it is now equals to 25 joules, which is matching with our third option. Hope every one of you it is clear to you. Moving on to our next slide, it is given that two forces each of magnitude 10 Newton act simultaneously on a body with their directions inclined to each other at an angle of 120 degrees and displaces the body over 10 meters along the bisector of the angle between the two forces. Then work done by each of the forces is. Let us try to assume that this is a body. One force is acting in this direction, other force is acting in this direction, and these two are separated by an angle of 120 degrees. Right, the bisector means the perpendicular would be this, the perpendicular bisector would be this. So the bisector angle is this. So now you say that one angle is 60 degrees over here, other angle is 60 degrees here, right? So with this is 60 degrees you have been considering. Now since the force is applied at an angle of 60 degrees with the vertical here, okay, now this force would be acting onto the body in this particular direction, okay, which is now equals to F sin 60 over here, F sin 60, and along the vertical direction it is now equals to F cos 60. Due to this force along the horizontal direction is F sin 60 in the opposite direction, and force along the vertical direction is F cos 60. As per the problem over here, it is given that the magnitude of the forces is 10 Newton and the displacement is 10 meters. So work done would now be equals to, work done is, strictly speaking, as per the definition F bar dot S bar, it is Fs cos 0 over here. In this problem, the displacement is also along the same direction, it is given that. So the applied force is equals to 2F cos 60. This is as per the definition we have been representing. Now with the given data from our problem, it is 2F cos 60 into S. It is 2 into F is equals to 10, cos 60 is equals to 1 upon 2 into the displacement over here is 10 meters here. 2 into would get cancelled off, which is now equals to 100 joules. Right, which is matching with our fourth option. Now moving on to our next problem over here. N identical cubes each of mass small m and edge L are on a floor. If the cubes are to be arranged one over the other in a vertical stack, then the work done is to be. So here we say that from the definition, work done would be equals to change in potential energy. So the initial potential energy would be equals to, as we have n number of blocks, it is n into m into g into L by 2 over here. Right. When these are arranged in a vertical stack over here, the final potential energy is n into m into g into n into L by 2. Right. So work done is equals to change in potential energy, and hence we say that our work done would be equals to n into mg into nl by 2, nl by 2, nl by 2 minus n into m into g into L by 2. So now here if we are trying to consider this over here, you can take this n into m into g into L by 2 common here. Okay, it is now n you are having additionally over here minus 1, n into m into g into L by 2 into n minus 1. So if you are trying to observe this, it is matching with our first option. Hope every one of you could follow this. Right? In this problem it is given that a chain of mass m and length L is overhanging from the edge of a smooth horizontal table such that 3/4 of its length is lying on the table. Work done in pulling the chain completely on the table is, when 3/4 of the length of the chain is on the table, 1/4 of the length of the chain is hanging. So you know that the work done in pulling 1/nth part of the chain onto the table is mgl by 2n square. So it is m into g into L by 2 into 4 square. Right, so which is equals to mgl by 16. 16 into 2 is 32. So work done would be equals to mgl by 32, which is matching with our second option. Moving on to our next slide. In this problem it is given that a 5 kg stone of relative density 3 is resting at the bed of a lake. It is raised through a height of 5 meters in the lake. If g is equal to 10 meter per second square, work done is. See, now every one of you, we need to know that relative density is just nothing but density of the solid by density of water, density of solid by density of water. Relative density is given by 3, is density of solid by density of water is 1000 kg per meter cube, 1000 kg per meter cube, and hence density of solid is now equals to 3 into 10 power 3 kg per meter cube. And we know that density is equals to mass by volume, and hence volume of solid is equals to mass by density of solid. Mass is equals to, mass of the body is 5 by density of the solid is equals to 3 into 10 power 3, 3 into 10 power 3. Okay, it is given to be this, right? So now here, if you could consider, I can write it as 5 ones and 5.6, or otherwise it is 1 by 600 meter cube. This is the volume of the solid. Now, when a solid is inside the liquid here, we know that its weight would be acting vertically downwards and force of buoyancy would be acting vertically upwards. So according to the Archimedes principle, force of buoyancy would be equals to weight of the liquid displaced, weight of liquid displaced, weight of the liquid displaced. So weight of the liquid displaced is equals to m into g of liquid we would try to represent, right? So mass can be written as volume of liquid displaced, volume of liquid displaced into density of liquid into acceleration due to gravity. Volume of the liquid displaced is equals to volume of solid into density of liquid into acceleration due to gravity. Volume of solid would be equals to, it is 1 by 600, density of liquid is equals to 1000 kg per meter cube into acceleration due to gravity is 10. So these two would be cancelled off over here. So it is now equals to 100 by 6, or otherwise which is 50 by 3 Newton, right? Now weight is equals to mg. So weight is equals to mg, mass is equals to, its weight is equals to mg, weight is equals to mg, mass is equals to 5 kg into g is equals to 10, which is equals to 50 Newton. So now your work done is equals to, 50 minus 50 by 3, 50 by 3 into the displacement is 5. Okay, so it is 50 can be taken common, 1 minus 1 by 3 is 2 by 3 into 5. Right, it is 5 5s are 25, 25 into 2 is 50, so it is 500 by 3 joules, 500 by 3 joules, which is matching with your first option, right? Moving on to our next slide, a plate of mass m, okay, breadth A and length B is initially lying on a horizontal floor, with length parallel to the floor, breadth perpendicular to the floor. The work done to erect on its breadth is, see, as per the situation over here, initially it is given that, initially if you could observe this, the plate is like this. The breadth is like this over here. Breadth is A. This is the breadth A. And this is the length B. Now how much work is to be done in tilting this such that this is our final situation? Now this is A and this is B. Okay, this is the final situation over here. So now here we would try to say that our work done is equals to change in potential energy. So now potential energy is mg into h. So the center of gravity lies exactly at the center. So it is final potential minus initial potential. Final potential energy, if we are trying to consider, it is mg into b by 2 minus mg into a by 2. Initially center of gravity lies exactly at the center, which is at a distance of a by 2. So now here it is equals to mg by 2 into b minus a. This is the work done, which is matching with our third option, right? In this problem it is given that a block of mass 10 kg slides down a rough slope which is inclined at 45 degrees to the horizontal. The coefficient of sliding friction is 0.30. When the block has to slide 5 meters, work done on the block by the force of friction is nearly. So now here, if you could consider that when the block is sliding down the inclined plane, displacement acts in this direction, frictional force acts in this particular direction. We were asked to calculate work done by the friction. Now if you look at the diagram, force is opposite to, frictional force is opposite to the displacement. So Fs cos 180 here, cos 180 is equals to minus 1 into F into S. F is equals to mu into N into S. Now here it is minus mu is equals to 0.30 into M is equals to 10 into G is equals to 10. Cos 45 is 1 by root 2 into the displacement is 5 here. Here every one of you know that your N is equals to mg cos theta. That is what I have represented here. So now here 5 3s are 15. It is multiplied by 100 over here. So it is now equals to, okay, 5 3s are 15 over here into 0.15 into 10 power 2 into 1 by root 2. Multiply this with root 2 and divide this with root 2 over here, which is now equals to 75 into root 2 with a negative sign. So the work done by the friction is equals to minus 75 root 2, right? Hope everyone you could follow this. Moving on to our next slide. See here it is given that a block of mass m is suspended by a light thread from an elevator. The elevator is accelerating upwards with uniform acceleration A. Work done during t seconds by the tension in this thread is, so work done is equals to F bar dot S bar. Okay. Now when you happen to consider an elevator like this, its tension would be acting vertically upwards. The elevator would also be moving in the upward direction. So displacement and tension, tensional force both are acting along the same direction. So it is Ts cos 0 over here. So when the elevator is accelerating upwards with an acceleration A, the tension would be equals to m into G plus A into S. So it is m into G plus A into, initially elevator is at rest, ut plus half A into T square. So it is m into G plus A into t square, m into g plus a into t square, which is matching with our first option, right? Moving on to our next slide. If 250 joules of work is done in sliding a 5 kg block up an inclined plane of height 4 meters, what is the work done against friction? So when you happen to consider the work done against friction, work would be done by the applied force, work would be done by applied force, work would be done by the applied force, as well work would be done by the gravitation, work would be done by gravitation, work would be done by gravitation. So now as per the problem, it is given that 250 joules of work is done by the applied force plus the work done by the gravitation, it is m into minus g into h. So now here it is 250 minus mass of the body is equals to 5 kg, g is equals to 10 into the height through which it was raised is 4, right? So now this is 250 minus 200, which is 50 joules, which is 50 joules, which is matching with our first option. Hope everyone it is clear to you. I suppose this session is useful to you. Thank you.